Good day, class. Welcome to another lesson. My name is Jenny, and I love science. I like to make videos to help you understand concepts in biology, chemistry, and physics. To receive my latest video, please subscribe and click on the bell icon to be notified of my latest post. Why is it useful to know the number of valence electrons in an atom? The number of valence electrons in an atom is useful to determine the number of bonds possible. You can use the group number on the top of the periodic table to know the number of valence electrons in each group. You can know the number of valence electrons from group 1, 2, and group 13 through 18. How do you know the number of valence electrons an atom has? The periodic table can help you determine the number of valence electrons. Elements in certain groups have the same number of valence electrons. In group 1, the total number of valence electrons is the same as the group in which they are, so it's 1 valence electron. In group 2, on all the way 13 through 18, the number of valence electrons is the atom equal to the 1 digit of the group number that the element is found. Helium is an exception to the rule. Atoms of helium have 2 valence electrons. Determining the number of valence electrons for elements in group 3 all the way through group 12 is a bit more complicated. The number of valence electrons may vary. What do the dots on an electron dot diagram represent? They represent the valence electrons. In 1916, a chemist named Gilbert Lewis developed a method to show an element's valence electron. He developed the Electron Dot Diagram, a model that represents valence electrons in an atom as dots around the element's chemical symbol. Electron dot diagram can help you predict how an atom will bond with other atoms. Dots represent valence electrons, and they are placed one by one around the element's chemical symbol until they are all used. Some dots would be paired up, others will not. The number of unpaired is often the number of bonds an atom can form. What are the steps for representing electron dot diagrams? The first step is to identify the element's number and chemical symbol on the periodic table. The second step is to identify the number of valence electrons. This equals the 1 digit of the group in which the element is found. For example, carbon in group 14 of the periodic table has a 4 valence electron. This is because carbon's valence electron represents the 1 digit of the group number. The third step involves drawing the electron dot diagram. Start by placing 1 dot at a time around the chemical symbol. You start at the top, right, bottom, left, and continue drawing the dots until all the electrons are used. The fourth step is to determine if the atom is chemically stable. Atoms are chemically stable if all the dots on the electron dot diagram are paired. For example, carbon has 4 unpaired dots around its symbol. Therefore, carbon is chemically unstable, whereas argon has all dots paired, and therefore argon is chemically stable. The last step is to determine how many bonds this atom can form. Count how many bonds are unpaired. For example, around carbon we have 1, 2, 3, and 4 electrons that are unpaired. Therefore, carbon can form 4 bonds around its chemical symbol. Argon has no unpaired electrons. Therefore, argon cannot form any bonds with other atoms. Quick review questions. What are electron dot diagrams useful? An electron dot diagram shows the pair and unpaired valence electrons of an atom and they are useful to determine how many bonds it can form. An atom of argon has 8 valence electrons, which helps it to keep it stable. Just like a racing boat has 8 oars, it helps it to keep it stable. A fun fact, a valence shell. The outermost ring of an atom is also known as the valence shell. It is the area where the valence electrons orbit around the nucleus. Some atoms, such as neon, have a full electron shell. Others, such as lithium, has an almost empty electron shell. Since the American chemist Albert N. Lewis developed the method for drawing dots around the chemical symbol to represent the valence electron, his method is known as Lewis dot structures. Thanks for your support. You'll see me in the next video. Bye!